Right now, somewhere near your home, a rat is making a decision. Not a random one, a calculated one. It is scanning your yard, your garden, your foundation through its nose. The rat's olfactory system is one of the most precise detection instruments in the animal kingdom, capable of reading chemical signals at concentrations no human instrument could measure before this century. It knows your space better than you do. But here is what it does not know yet. You are about to change the chemistry. If you are watching from the US, hit the like button before we get into the list. It costs nothing, and it genuinely helps this channel reach more homeowners who need this information. Plant number 1. Peppermint. Mentha piperita. Crush a leaf, and the scent hits instantly. Sharp, cooling, electric. For a human, it is invigorating. For a rat, it is something closer to an assault. The active compound responsible is menthol. Peppermint essential oil carries menthol concentrations of up to 40%, and this compound binds to the TRPM8 receptor, a cold-sensing ion channel in the nervous system. In rats, overstimulating that receptor does not produce a pleasant cooling sensation. It produces distress, an aversion response the animal cannot reason its way out of. But menthol is not working alone. Peppermint also contains menthone, menthol acetate, and a dense range of secondary terpene compounds. Together, they create a chemical profile that the rat's brain classifies as dangerous. In nature, volatile terpenes at that concentration typically signal toxic plant matter or chemical decomposition. The rat's nervous system evolved over millions of years to move away from those signals, not toward them. Ancient Romans documented peppermint's use in protecting stored goods. It was strewn across granary floors and woven into thatching. Medieval apothecaries recommended it against vermin. This was not superstition, it was applied observation, repeated across generations. Planted densely along your home's exterior walls, especially near any point where pipes or cables enter the foundation. It spreads aggressively. Use containers or landscape edging to keep it in bounds. Trim it regularly. Every cut releases a fresh burst of volatile compounds, which means trimming actually increases its effectiveness rather than reducing it. Plant number 2. Lavender. Lavandula angustifolia. Lavender has a reputation for being gentle, calming, a scent associated with clean linen and good sleep. Rats do not share that association. The primary volatile compounds in lavender, linalool, linalool acetate, and camphor, are individually mild to the human nose. Together, in the concentration produced by a dense lavender planting, they form a chemical environment that rodents are neurologically programmed to avoid. Linalool has been studied extensively in pest research. It functions as a natural insecticide and has documented repellent effects across a range of pest species. In rodent studies, animals exposed to linalool-heavy environments spend significantly less time in those zones and show elevated stress markers when forced to remain. The camphor component adds another layer. It interacts with the rat olfactory system similarly to menthol, triggering receptors associated with chemical irritation rather than pleasant fragrance. To a rat's nose, a lavender hedge is not beautiful, it is a wall of warning signals. Medieval French farmers planted lavender along the perimeters of kitchen gardens as standard agricultural practice, not for aesthetics, but because they had observed across generations that rats did not nest where lavender grew. The practice was so common it was considered basic knowledge. Plant lavender in long, unbroken runs along garden borders. It is drought-tolerant, thrives in poor, well-drained soil, and produces its highest concentration of volatile compounds during long, hot summers, exactly when rat pressure peaks. Let it mature into a hedge. The thicker it grows, the harder the barrier becomes.
Plant number 3. Marigolds. Tagetes. Marigolds are almost universally underestimated. Most gardeners know them as cheerful, easy-to-grow annuals, What most gardeners do not know is what they smell like to a rat. The pungent, slightly acrid scent that makes marigolds polarizing to humans comes from a class of compounds called thiophene, sulfur-bearing organic molecules produced in the roots and leaves, volatilizing strongly in warm temperatures. To the rat olfactory system, thiophenes register as a serious chemical threat. The scent profile overlaps with compounds associated with decomposition and toxicity in the natural environment. Marigolds also contain limonene and other terpene compounds that add to their overall chemical complexity. The combined profile is one that rats consistently avoid in behavioral studies. The historical use of marigolds as companion plants in vegetable gardens was not only about insect pests. In traditional agriculture across Central America, South Asia, and the Mediterranean, marigolds were planted in deliberate rows around food crops. The observation was consistent across cultures: fewer rodents in gardens where marigolds were integrated. Plant marigolds in dense borders around vegetable beds and compost heaps. The key word is dense. A few scattered plants will not create the chemical threshold needed. A solid row of French marigolds planted closely creates a scent corridor with genuine deterrent power. Replant them annually and avoid deadheading too aggressively. More flowers mean more volatile production, and that is the entire point.
Plant number 4, sage, Salvia officinalis. The Latin genus name, salvia, from the word for salvation, suggests something of this plant's historical stature. It has been a culinary herb, a medicinal plant, and a ceremonial plant across cultures for thousands of years. And, quietly, in the background of all that history, it has also been a pest deterrent. The dominant compound in sage is thujone, a terpene ketone with a sharp, medicinal, almost resinous scent. Thujone, alongside camphor 1.8-cineol and borneol, create a complex volatile profile that the rat olfactory system finds deeply aversive. These compounds interact with neurological receptors in ways that generate active avoidance behavior. The rat does not simply lose interest in a space that smells of sage. It actively dislikes being there. Medieval monastic herb garden layouts documented sage specifically positioned at the borders of storage areas. Monks understood that certain plants created zones that pests would not enter. Sage was consistently among them. As a garden plant, sage is remarkably practical. It is a woody perennial in most temperate climates, drought-tolerant, low maintenance, and becomes more chemically potent as it matures. Old, established sage plants produce denser volatile concentrations than younger ones. This is a plant that gets better at its job. Plant sage along garden borders, near shed entrances, and in the spaces between raised beds. Brush against it occasionally to release fresh oils. It responds well to being noticed.
Plant 5. Garlic, Allium sativum. There is almost no culture that has grown food that did not also grow garlic. It is one of the oldest cultivated plants in human history, and its properties as a deterrent against insects, against fungi, against rodents were understood long before anyone knew the chemistry behind them. The chemistry begins when garlic tissue is damaged. An enzyme called alliinase converts alliin into allicin, one of the most biologically active sulfur compounds in the plant kingdom. The volatile sulfur molecules that result, dimethyl disulfide, dimethyl trisulfide, and a range of related compounds, disperse rapidly into the surrounding air. To a rat, these sulfur signatures read as alarm chemistry. They overlap with chemical signals that rodents themselves use to communicate danger: territorial markers, stress signals, predator scent. A space saturated with garlic's volatile sulfur chemistry sends a message to the rat nervous system that this environment is not safe. There is nothing subtle about it. Plant garlic throughout the kitchen garden, interspersed between vegetable rows, along borders, and near any areas where rat runs have been observed. Leave some plants to bolt and flower in summer. The scape and flowers significantly increase the above-ground volatile presence. Older, undisturbed garlic produces the strongest deterrent effect. Garlic also improves soil health, repels a range of insect pests, and provides one of the most fundamental ingredients in any kitchen. It is doing more than one job at all times. If this list is useful so far, there is a Complete Plant Care Handbook linked in the description below. Placement strategies, companion planting, seasonal care, all of it in one place. Worth grabbing before you head to the garden center.
Plant number 6. Onions. Allium cepa. Onions and garlic share their chemistry in broad terms. Both are alliums. Both produce sulfur-based volatile compounds that rats instinctively avoid. But the deterrent mechanisms are not identical, and planting both creates a more layered chemical environment than either achieves alone. The volatile compounds in onions, propanethiol S oxide, dipropyl disulfide, and related sulfides, are produced differently from garlics and disperse through the environment at a different rate. Propanethiol S oxide is the compound responsible for the eye-watering sensation when cutting onions. In rats, it functions as a direct olfactory irritant at the concentrations produced by dense planting. The rat's sensory system is not simply detecting an unpleasant smell, it is registering a chemical threat. Historically, onions were companion planted alongside root vegetables and grain crops across Europe and Asia, not only for their deterrent effects on insects and fungal pathogens, but because rodent pressure was consistently lower in beds that included alliums. Plant onions in thick clusters along borders and throughout vegetable beds. Ornamental alliums, the tall, globe-flowering varieties, provide the same sulfur chemistry with significant aesthetic impact and are particularly effective when planted in large numbers. Do not discard the outer skins and trimmings too quickly. Even decomposing allium material continues to release deterrent compounds into the surrounding soil.
Plant number 7. Daffodils, Narcissus. Daffodils operate through a different mechanism than anything covered so far, and it is worth understanding clearly. Daffodils contain licorin and other alkaloids concentrated primarily in the bulb and throughout the plant tissue. These compounds are toxic, genuinely toxic, not merely irritating, to rats and most other rodents. A rat that consumes daffodil material will experience severe gastrointestinal distress. The rat's nervous system, through learned aversion and in some species, through instinctive chemical detection, identifies the alkaloid signature of daffodils as a serious threat. This is not primarily a scent deterrent. It is a chemical danger signal operating at the level of the plant's molecular identity. The practical result is straightforward. Rats will not dig through daffodil bulbs to reach other bulbs beneath them. They will not establish runs through dense daffodil plantings because the chemical profile of the soil and plant material marks the area as hostile. They learn to route around it. Plant daffodils as a border around the property perimeter and along fence lines. They are perennial, require almost no maintenance once established, and multiply reliably year after year. They also serve as protective underplanting around tulip and other bulb varieties that rats actively target. A ring of daffodils around a tulip bed creates a chemical boundary that most rats will not breach. The additional benefit? Nothing in a daffodil planting is edible to a rat. There is simply no reason for them to be there.
Plant number 8. Rosemary. Salvia rosmarinus. Rosemary is the most architecturally useful plant on this list. A mature rosemary shrub can reach 1.5 meters in height and spread nearly as wide. It becomes a physical barrier as much as a chemical one. The primary volatile compounds, 1,8-cineol, camphor, alpha-pinene, and borneol, form a dense, resinous, piney profile that the rat olfactory system finds aversive. Camphor and 1,8-cineol in particular interact with chemosensory receptors in ways that produce active avoidance rather than mild discomfort. In behavioral studies, rodents exposed to these compounds reduce exploration, increase exit behavior, and show measurable physiological stress markers.
Rosemary was documented as a protective plant around Roman granaries. It appears in medieval monastery and estate planting records specifically positioned at the entry points of food storage areas. The knowledge was consistent across centuries. As a garden plant, rosemary is exceptionally practical. It is an evergreen perennial in most temperate climates, providing chemical coverage year-round, not only during the growing season. It thrives in poor, well-drained soils and becomes denser and more potent with age. Planted at the corners of raised beds, flanking shed and outbuilding entrances, and near any foundation entry points. In colder climates, where rosemary will not overwinter outdoors, grow it in large containers that can be brought inside during frost and return to their positions in spring. It holds a perimeter quietly, the way it always has.
Plant number 9, Chrysanthemums, Chrysanthemum cinerariifolium. Chrysanthemums are not usually described as a pest control plant. That is a significant oversight because they contain one of the most effective natural pest repellent compounds known to science, pyrethrins. These are naturally occurring insecticidal compounds found in the flower heads of certain chrysanthemum species. Pyrethrins work by disrupting sodium ion channels in insect nervous systems, causing paralysis. In mammals, including rats, the dosage required for lethality is far higher, but the olfactory detection of pyrethrin chemistry triggers a strong behavioral avoidance response. Rats are extraordinarily sensitive to environments that signal neurological threat. The volatile compounds from pyrethrin-rich flower heads create exactly that signal. Pyrethrin extracts from chrysanthemums are now the basis of a multi-billion-dollar pesticide industry. The commercial versions are synthesized and modified. The original compound, sitting in the flower head of a living plant, does the same work at lower intensity, persistently, continuously, without application intervals or chemical runoff. Plant chrysanthemums in dense groups around vegetable beds in compost areas. Deadhead regularly to encourage continuous flowering. The highest pyrethrin concentration is in fully open flower heads, so maintaining bloom is maintaining deterrents. In autumn, when most other plants are dying back, chrysanthemums are still producing actively, extending chemical coverage into the season when rats begin seeking winter shelter.
Plant number 10, catnip, Nepeta cataria. Yes, catnip attracts cats, that is relevant and worth addressing. But the deterrent mechanism that makes catnip effective against rats is entirely separate from the feline response, and it is chemically sophisticated. The primary active compound in catnip is nepeta-lactone, a bicyclic terpene produced in high concentrations in the leaves and stems. In rats and a wide range of insect species, nepeta-lactone functions as a potent repellent. In controlled laboratory studies, it has been shown to be approximately 10 times more effective as a mosquito and cockroach repellent than DEET. In rats, the mechanism involves direct olfactory aversion. Nepeta-lactone triggers receptors associated with chemical threat rather than neutral detection. The scent to a rat is not simply strong, it is alarming. It activates an avoidance response that the animal does not overcome through habituation at normal garden concentrations. Now, the secondary effect. A catnip planting will attract neighborhood cats, and a property with active cat presence is a property that rats treat as a predator zone. Rats detect cat urine and dander in the environment and process that information as a serious danger signal. Catnip introduces that chemistry indirectly and consistently. Plant catnip in dense patches near garden borders, compost heaps, and along fence lines. It spreads readily. Contain it if needed. Crush the leaves occasionally to release fresh nepeta-lactone. It is low maintenance, highly effective, and costs almost nothing to establish. And as a final note, a garden that deters rats and draws in cats is a garden working on 2 levels simultaneously.
Rats are not bold. They are cautious, deeply risk-averse creatures governed almost entirely by scent.
Before taking a single step into unfamiliar territory, a rat has already run a full chemical analysis. Is there a predator here? Is there competition? Is there something in this environment that signals danger? When the answer is yes, when the scent profile of a space sends the wrong signal, the rat does not investigate further. It turns around. It finds somewhere else to be. The 10 plants on this list exploit exactly that. They produce volatile compounds, essential oils, and chemical signatures that rats are neurologically wired to avoid. Not through poison, not through traps, through scent, through a biological conversation happening at a molecular level, one that farmers and homesteaders have relied on for thousands of years. What the ancients planted by observation and inheritance, biochemists can now explain with precision, and it still works.
These 10 plants work through the same underlying logic. They speak in the language that rats actually understand. Chemistry, scent, the molecular conversation between plants and animals that has been happening for millions of years. This knowledge was not invented recently. It was practiced in medieval monastery gardens, in grain farming communities across China, in Egypt, and the Mediterranean, in every agricultural tradition that ever had to coexist with rodents, which is every agricultural tradition that ever existed. Somewhere in the shift to industrial pest control and synthetic chemistry, it stopped being passed down. It sat in old planting records and botanical manuscripts and the quiet knowledge of people who lived close to the land. These 10 plants are a practical, affordable, genuinely effective layer of protection. They will not eliminate a severe rat problem on their own, but planted strategically along foundations, at garden borders, near compost heaps and outbuildings, they create an environment that rats find deeply hostile. They do not poison the soil, they feed pollinators, they provide herbs and flowers and food, and they work. Drop a comment below. Which plant on this list are you planting first? Subscribe if this was useful. And the Complete Plant Care Handbook, placement strategies, companion planting, seasonal care is linked in the description below. The knowledge was always there. Now it is yours.